The Raspberry Pi 5 is incredibly powerful, making it perfect for a bunch of different applications. However, it comes with one massive drawback. It's tethered to a wall. Now you might be thinking, making the Pi portable should be as easy as connecting it to a power bank, but this isn't always the case. The Pi 5 is incredibly picky with its power requirements. It needs 25 watts from 5 amps and 5 volts. Any sort of deviation from the standard can cause things like throttling to entire system failures. But you have to remember, not all watts are the same. Power, measured in watts, is a product of voltage, which is measured in volts, and current, which is measured in amps. Most power banks designed around the USB standard cap the amperage and increase the voltage to increase the power rating. Without the correct configuration, we can run into a lot of different issues. Furthermore, because the USB cable can't communicate with the Pi, when the power bank hits zero, the Pi just shuts off without any sort of warning. Since your Pi's OS is constantly managing files in the background, if this happens at a critical moment, you can corrupt your OS and lose all the data that you have. But we don't just need a battery. We need a smart power supply that communicates directly with the Pi CPU and a way to monitor it so it doesn't die unexpectedly. So that's where these come in. This is a UPS or uninterruptible power supply. With this, we'll be able to monitor our battery alongside other system specs with a custom interface that I've built. Let's get into the assembly. Before we actually do anything, we need to enable the I2C interface so that the UPS can communicate with the Pi. So in our terminal here, we go to the Raspberry config, and then we can go into interface options, and where we see I2C here, we can enable this interface. And once we reset the Pi, everything should be set up. Now for launching the program, we just need to go into our project folder and start the application. So here I have it on my desktop, and we can go into this folder. It's called RBerryLink Monitor. And here we can see all the project files, and we'll just start up the pi-dashboard.py file. So starting up, it takes around 2 minutes to get past the splash screen. And this is mainly for the algorithm to calculate an accurate charge or discharge rate and the associated times with that, like the time until full charge or time until 0%. You could change this in the settings. However, you might find that it takes a little bit longer to read accurate data in regards to it. So here we can see all of our system specs. In this first section, we have all our battery information. Next, we can see our CPU and memory information. After this, we have disk information, then networking information. And at the bottom here, we have some settings that persist. So we have a safe shutdown, which will give you a warning if it's close to 0%, or whatever you set it at. Right now, I have it set at 13%, but the default is 5%. So once the battery capacity reaches that threshold, it'll give you a warning so you can safely shut down. There's also a setting for auto start on boot, so you don't have to go through all of these steps when starting up every single time. If you turn this on, it'll just start automatically. You can also turn this off if you don't want this to happen. But I find it makes it a whole lot easier just having this on and opening it whenever I need to, instead of having to go into like the terminal and find all of this information. So ultimately, it just makes it a whole lot easier when using this. So to see how our interface responds to live changes, we're going to be running this stress test. So you can see our discharge rate is hovering around 15%. It's going from around 15.4 to around 14.5. And this is just an average sense of the discharge rate. So when I run the stress test, we're going to see things like the CPU usage and temperature increase instantaneously because this is live data that's being pulled and reflected. However, things like our discharge rate and our time until empty are going to take a little bit longer because I'm using a smoothing algorithm to collect data over a window to give us an average sense of how our battery is responding to whatever we're doing with the Pi. So here I have this test open in the terminal, so I'm going to start it now. And you can see our CPU usage and temperature rise almost instantaneously. And we should see a slow rise in the discharge rate alongside a slow fall in the time until empty. So we can see our discharge rate is rising and our time until empty is getting shorter. So we can see as our test finishes, our discharge rate is going to take a little bit to go back down. And this is just because, as I said, I'm using a smoothing algorithm by taking the time window and getting a sort of average. I think this is a lot better than always looking at instantaneous data because you can have things like spikes that can, have a great effect on the discharge rate and the time until empty. But with this, we're able to get like an accurate sense of how our usage is affecting our battery. So as you can see, this setup is extremely helpful if you want to take your Pi anywhere. I hope you guys enjoyed the video and make sure to subscribe if you want to see some of the projects I have planned out with this.